Hey Lizzie, sorry for the delay. So I've got the assignment here that you worked on pulled up first, and I just kind of want to walk through it with you, but I also want to talk about a couple of things maybe before we get started. So your mom shared that this, I believe, is a retake for you, this course. And so now we're in our second attempt of taking algebra, which is fine. Algebra can be a very tricky topic for students, particularly depending on how well they mastered things maybe in 8th grade or 7th grade or 6th grade, because math really does truly build on itself. So as you go through the lessons, my first question is going to be, how are you handling the instruction videos? So in my math class here at school, students are required to take notes. So they have a composition notebook, which is one of those smaller size notebooks, and it doesn't have a spiral on the side. It has like just like a tape over it because it's bound together using thread versus using a spiral. I prefer those because they hold up a lot longer during the school year. They get thrown in backpacks and things like that, and the spiral doesn't get bent or fall out. Pages don't tear out of it easily, so I tell my students, this is your math notebook, and you should be taking notes as you kind of go through these instruction videos. So that's the first thing I want to ask, are you taking notes? If you're not taking notes, I'm going to ask that you start taking notes anytime you get to an instruction. And my hope is that you are kind of writing down what you're seeing on the screen, and maybe even writing down what you think are important pieces of information that are shared with you in those videos, those instructional videos. You can use this math book then as a tool to help you as you go through the assignment and through the quiz. Because to just try to sit and listen and then remember everything that's said is very difficult. So writing notes is just another method to help students remember different topics, right? So as you're writing things down and listening, you have a better chance of remembering because you're also writing. So I would start there with notes. There are guided notes. I can't remember if there are guided notes here. But you should know how to access those for other classes, so you can check to see if there are guided notes here. Maybe let me know on that just so that I know in the future if algebra has guided notes. Okay, so let's take a look at this lesson. Basically, when we're analyzing tables, we're using tables kind of down the line to help show a story or tell a story. So in this table, it says, what is the x-intercept of the continuous function shown in the table? So remember from the lesson that an x-intercept is where the graph crosses the x-axis. Now I've just made up this graph. It does not match that table, but x-intercepts are here. They're where the graph, again, crosses the x-axis. Remember, this is the x-axis and this is the y-axis. And what's important to know is that all x-intercepts look like this, right? 0 or x comma 0. All x-intercepts have a 0 in the y spot. Okay, so this cannot be the answer and that cannot be the answer because neither one of those values have a 0 in the y spot of the ordered pair. So what you're looking for is the value or the point, the ordered pair that has a 0 in the y. So as you look down, remember this is the x column, this is your output or your y column. As we look down here, we're looking for where is there a 0 in the y spot. That is your x-intercept. It's kind of like a flip-flop thinking, I say, where it's the x-intercept but y is 0. Okay, so the y is a 0. You chose the answer where x is 0. That's actually the y-intercept. Okay, frame 2 says using only the values given in the table for the function, and it gives the function what is the largest interval of x values where the function is increasing. So we're looking for where are the y values getting bigger. Not where are they the biggest, but where do they increase as you move through this table. So it looks like, let me see if I can click on any of this. Whoops. Okay, so you're just able to type in values, the largest interval of x values where the function is increasing. So from here to here, whoops, I'm going to switch back to my pen. From here to here, okay, it's getting smaller. I'm going to use a negative symbol and a positive symbol. From here to here, it's also getting smaller. So right now it's decreasing, and I'm looking here. Okay, when we talk about increasing and decreasing, we're talking about what are the y values do as we go, what are the y values doing as we go through the function. So there it's decreasing because 3 is less than 18. Here it's decreasing because 0 is less than 3. Now we are increasing. Now we are increasing. And now we are decreasing again. So we're looking at the y's, but you're giving the x's as the answer. So we're talking about from here to here. This is where the graph was increasing. So from -1 to 1, the function is increasing. It's doing something like this. It's doing something like this. It's getting bigger or taller or steeper as you move through the x values. So you're looking at the y's to see that the function is getting bigger, but your answers are the corresponding x values. Frame 3, it does look like we selected one answer correctly, but then you can see the gray x's, those are the ones, or sorry, the gray check marks, those are the ones we missed. Okay, so predict which statements are true about the intervals. The first one says that when f of x is greater than 0 from -infinity to 3. Well, that's not true because from -infinity to 3, we have 2 answers that are not greater than 0. Okay, that's the whole table. So from -infinity to 3, it's not always greater than 0. Okay, that only happens. Then when f of x is less than or equal to 0 over the interval from 0 to 2. So we're looking from 0 to 2 in our x values, and then are the y values less than or equal to 0? Yes, that one's equal to 0. Yes, that one's less than 0. Yes, that one's equal to 0. So we should have checked that second option. I have to do some erasing here while we work. Okay, the next one that's incorrect says that the function is less than 0 from -1 to 1. So from -1 to 1, and you didn't pick this one, but it's correct that it should not have been selected because from -1 to 1, we have a positive number and a number that's equal to 0. So we don't have all answers that are less than 0. Then we also should have selected the next one. It says the function is greater than 0 from -2. So you're looking from -2 to 0. From -2 to 0. It says that the function is greater than 0. Oh, but it doesn't include 0. Okay, so now remember the difference between a bracket and a parenthesis. Parenthesis means we're not including those numbers, so we're actually not looking at -2 and 0. We're only looking at the value we have here. So something happens between 0 and 3 where it gets bigger, and then it goes from 3 back to 0, but all of those numbers are greater than 0. And then you did select the last one. So again, a difference between the parentheses and the brackets. If we have parentheses, like this, then we're talking about 0 and 2, and if we have, or brackets, sorry, if we have brackets, we're talking about 0 and 2. If we have parentheses, we're not actually talking about 0 and 2, but everything in between them. So that's why this one works. This fourth one here works, even though we're not actually talking about -2 and 0 themselves, because they're not, 0 is not greater than 0, but because of the parentheses, we're not talking about these actual values. So something might happen on this graph, 1, 2, 3, and this is 1, 2. So we're talking about -2 to 0. At -2 it is 0, and at 0 it's 0, and it goes up to 3. So we're, might do something like this. Goes up and comes back down. But again, we're talking about right just on the other side of 2 and just before -2 and just before you get to 0. So in between those dotted lines, not including the points -2 and 0 themselves, it is greater than 0. Analyze the table of values for the continuous function. A local maximum. Where is it the highest? Where is it the lowest in an area? So, here it's getting bigger. Oops. So we're increasing. We are increasing. We start decreasing. We're still decreasing. And now we are increasing again. So this happens what interval is it happening at? So again, you're not picking an ordered pair, you're picking the x values at which it happens from. So you can see we're increasing -3 to -2, -1, and then once we get to 0, it starts going back down again. And then the opposite is true. If we look at from 0 to 2, what's happening here? So it's decreasing, decreasing, and then it starts to go back up. So in between 0 and 2, we do have a local minimum. Same thing kind of happens here, okay? It's getting bigger and bigger and bigger, and then it starts to, at some point here, it starts to go back down again. So from -2 to 0, you do have that also local max. If it helps to plot this stuff out, get some graph paper, right? Just draw yourself a graph where you plot these values, and then it becomes a lot easier, I think, visually to see where do we have local maxes and where do we have local mins. Which table shows a function that is decreasing only from -1 to 1? So -1 to 1, we're decreasing, and we're decreasing. So 3 to 0, 0 to -3. Here, eight to 0 is decreasing, 0 to -8 is decreasing. Oh, but then it's also still decreasing here. So it says only over that interval. This one keeps decreasing. This one increases, that's why it works. This one keeps decreasing, so it says only over that interval, but because this one keeps going down, that's why this one doesn't count. Here again, we're decreasing, but then we're increasing. 0 to 3 gets bigger, so this one doesn't work. And then we are getting bigger and we're getting bigger, so that one doesn't work. Again, it said decreasing, so we're trying to look at the y values and make sure that they are going down. But then after this point, they would go back up again. Table relates a function that models the height of a rock after it's dropped. Okay, so we're up here somewhere, I don't know, standing on a table. Here's my table. Here's my rock. We drop it. The rock is going to hit the ground at 0. Okay, when this is the height. So when the height is 0, it hits the ground. But you're going to notice that there is no 0 here. Okay, so it's at 20 feet, then it's at 18.8, then it's at 15.1. I'm standing on a really tall table because it's 20 feet in the air. Then it's 9, 0.4. Then we get negative. I don't know, maybe there must be a hole in the ground, right? So now we have a hole in the ground. So somewhere between here, we cross over that 0, that ground level mark. Between 0.4, so if you think about a number line, okay, here's 1, here's 0, there's -1. So at 2 seconds, it's at 0.4, and then at 2.5 seconds, it ends up, way back here at -10.6. So somewhere between 2 and 2.5 seconds is when you should be putting X values in there. It looks like you put in this X value and then you entered that Y value. So time, it says, when does the rock hit the ground? The rock hits the ground between blank and blank seconds. So you should only be given answers from this part of the table, and it happens between 2 and 2.5. Ball is dropped, hits the ground sometime between 4 and 6 seconds. So somewhere between 4 and 6, you should see a positive to a negative height. And here it is, right? Between 4 and 6 seconds, it was positive and now it's negative. Again, it must be falling in a hole because 0 would be when it hits the ground. So that's this table here. Table represents the height of a ball that's thrown up from the roof of a building. Okay, so here's our building. Okay, here's the rock, and it's going to be thrown up. So let's talk about what this rock is going to do. First, it's going to go up, and then it's going to come back down. So let's focus on the ones we should have picked that we didn't, and the one that we shouldn't have picked that we did. Okay, you did check the one that says the green check mark you did pick. The 2 grayed out X's you did not select. So it says the ball is at the same height as the building between 8 and 10 seconds. So when you're throwing a ball, sorry, this one's a ball. When you're throwing a ball from a building, this building is like ground zero. It's considered 0 feet. Okay? It's at the same height as the building between 8 and 10 seconds. And so that is true. So everything above this is positive and everything below that point is negative. And that's where you see the switch in the Y's from 6.4 to negative 90. The ball hits the ground between 8 and 10 seconds after it is thrown. So you can see it going up, and then it starts to come back down. Here's where it's coming back down. Okay, so they're actually treating... Right, okay, so the ball doesn't hit the ground between 8 and 10 seconds. That's where the ball is now lower than the, below the building. So wherever you're throwing a ball from, if you're standing on the ground, then the ground is 0 height. If you're standing on top of a building, then the top of the building is height 0. So it's not hitting the ground here. It's passing the top of the, it's at the top of the building again. So there's your 8 to 10 second mark where it's back at the building level, and then you can see now we don't know if this might keep going, 14, 16, 18. We don't know how many seconds until this ball comes to a rest way down here. But these are negative values, and then these would be the positive values. So that's why that top one is correct and this one is not correct. Okay, if the table of the function contains exactly 2 potential turning points, one with an input value of -1, which statement best describes all possible values of m? So turning points, that's where something like this is happening. We're increasing and now we're decreasing. Okay, there's a turning point. We're increasing and now we're decreasing. There's a turning point. We're decreasing, now we're increasing. There's a turning point. So if the table of the function contains 2 turning points, okay, so let me look at everything else in the table before I try to make any conclusions about m. Okay, so what happens from here to here and here to here? We don't know because we don't know what m is. Here we are decreasing. We are decreasing. Now we're increasing. Okay, so here's a turning point. Decrease, 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 increase. So which of the following, what does it say again? Which of the following best describes the all possible values of m? So in this instance, 4 to 0 is decreasing, 0 to negative 4, still decreasing, negative 4 to 2, now we're increasing. So at negative 2, let's see, it can't be less than or equal to 4. Greater than negative, yeah, because, okay, so here's why this answer choice doesn't work, because it also has to be greater than negative 12. So m is kind of sandwiched in between negative 12. We want that same pattern. We want it decreasing, decreasing. So then m, the reason why that first choice you picked didn't work, yeah, it has to be less than 4, but it can't actually be equal to 4, because then we would have something like this in our graph, like a horizontal line. But it also has to be bigger than negative 12. So that's why this answer choice does not work, because it also has to be greater than negative 12. And that's what this inequality actually says. I know that these are kind of weird to read, but what that's saying is that m is between negative 12 and 4. Okay, so again, I know that that's a lot here. I would make sure you go back and watch that instruction video again. Anytime you don't do well on an assignment, I always encourage students to watch the instruction video again. You can watch those as many times as you want. And also to make sure that you're taking notes and then using that notebook as a math tool to help you as you move forward through the rest of the lesson. I am going to check out Khan Academy and see. I don't personally happen to have a video of this exact topic, so I'm going to check out Khan Academy and YouTube and see if I can't find just something else that might be helpful as well on just how we're reading, how we're using and analyzing and reading tables. Let me know if you need anything else.